Thank you so much, Beck, and welcome everyone. It's lovely being here, seeing actual humans and being able to interact with them after such a long period of limited social contact. And I'm particularly thrilled that you've chosen to tune in for this session on soils, which would have to be one of my favourite things to teach people about, but often is one of the harder things to pull people towards. So I hope that you'll come out being as awe-inspired by soil as I am. And I've got videos and I've got lots of photos and even some pretty daggy hand-drawn cartoons to help us get there along the way. And before I start, I also just want to acknowledge that I'm on Wurundjeri land today, and the soils around where I live are really different to the way that they used to be before this land was settled by Europeans. We know that the soil used to be very fertile here. It used to be soft and dark and spongy. And it was looked after and still is looked after by traditional custodians. Some of the native plants, like the Murnong yam daisy, I can't grow in the original soil in my block because it has changed so much that it actually just doesn't suit that plant anymore. And that's a pretty sad indictment really on the changes that have happened to soil in the last couple of 100 years. But what I am excited about is that we can bring soil back. We can bring it back from the brink. We can turn it around, we can make it fertile again, and that can happen in a surprisingly short period of time. So that is really, really good news. There's some crazy statistics out there that relate to soil. It was the UN's International Year of Soils a couple of years ago, and they worked out that we are losing soil at such a significant rate that we have about 60 years of fertile, farmable, what we call arable soil left, full stop, at the rate that we're currently drying it out, blowing it away, washing it away, degrading it and losing it. That's a pretty frightening statistic. And if you're struggling to put that into perspective, it's an area the size of Costa Rica, they tell me, every year. And I don't actually know how big Costa Rica is, but it's a country, so it must be pretty big. And that's the amount of soil that we're losing. So it's extremely important that we learn the things that we're going to talk about today as a culture, or many cultures, learn how to start caring for the stuff that feeds us, because it's the only stuff that can feed us at the end of the day. All our plants and animals rely on soil, except for very few exceptions. So soil is really about us staying healthy and well as people and looking after all the plants and animals around us. So I'm going to start sharing a screen with you, but we are going to pop back and forward, and I want to encourage you as we're going through to pop those questions in the chat window, and that's going to allow me to pause and clarify some points as needed as we go through. And it's also going to just allow Beck and Deborah to collect questions so that we can actually pause at key points throughout the session and come back to them. So let's go into some slides. And Becca, if you could just give me a verbal thumbs up that this is working.
Yeah, that's working.
Yeah, beautiful. All right, so here's a handful of my soil. And I love my soil. I sigh deeply when I look at it in the sunshine like this. It's like introducing you to an old friend because we spend a lot of time together. We know each other really, really well. So this is what my soil looks like. And I'm going to show you some photos side by side now of this soil. Now on the left, this is soil which has not been cared for. This soil is poor. This particular soil is very sandy. And on the right, I'm going to show you another more healthy soil. And I was actually, I think I was going to try and handle some on my desk, but I think it might just be a little bit complicated. So I'll describe them for you as you see them on the screen. If you were here with me, you would be able to pass them around. You'd be able to touch them and smell them. And I'd like you to imagine with the sample on the left, you're touching this soil and it's actually running through your fingers like a sandpit. It doesn't have very much smell. You can look at it and see that there's no structure, that all the little grains are separate. They're just kind of dusty. There's no form to that soil. If we move to the soil on the right, I'd like you to observe the colour difference. This soil is dark in colour and it looks a lot like a crumbly chocolate cake. Maybe your chocolate cakes look a little bit better, but it does look like a spongy cake. It's darker. Darker is an indicator often of a soil that is richer in organic matter, which we'll cover a bit later in the session. And that usually means it's more fertile and healthy. If you held this sample up to your nose and have a smell, you will actually smell something, but it's not unpleasant. It's a beautiful earthy smell. You're actually smelling some types of beneficial fungi that live in the soil. So it's a nice, pleasant smell, and there is a smell there. If you run your fingers through this soil, one of the things you'll notice is that it's got little crumbs and chunks in it. And in between them, there's air spaces. So it's actually got what we call a structure. This soil is well structured, whereas the soil on the left has no structure. It doesn't have any crumbs, it doesn't have any pore spaces. And then finally, as you're touching the soil on the right, you'd be able to feel a little bit of moisture, and it will feel spongy. So if I were to pour some water in the soil on the right-hand side, it would be greedily sucked up by all those lovely spongy crumbs. If I'm pouring the water on the left-hand side, actually a lot of that water is going to run off because the soil is very degraded, but the stuff that does run into it is going to fall through that sandy soil quickly and be lost. So the one on the right is what we're aiming for today. And the most exciting thing that I have to say about these two soil samples is that this is actually the same soil. This is soil before and after good management. And this is very, very achievable for you to do. And not even in that long a time. In the course of a couple of months, you can bring this type of soil around. So I hope that's good news for you as we get started, and really sets a picture of what we're aiming for the rest of the session. You may have clay soil, by the way. This is a very sandy soil. Don't worry, the advice is remarkably similar for both ends of that soil spectrum. And we'll come to that in just a moment. Okay, so the next thing is, when you dig a hole, and we need to go back to basics here, what do you see when you dig a hole? And at my place, you can see exactly what happens in the photo on the left. As you start to dig, you may see really distinct changes in the colour and the texture of the soil. And these are layers that we call soil horizons. As a bit of a basic introduction to soil horizons, the different geological processes have created them. And in the profiles that you see on the right, you can see that bedrock, which underpins us wherever we are, but has slightly different constitutions depending on what type of geology formed our area. It might be an old seabed, for example, or it might be granite boulders, or it could be lots of different things. But that bedrock slowly weathers away over millions and millions of years. And as we move up towards the surface, the geological processes start to be less dominant. And what takes over are the living processes. So at the very top, in what we call the topsoil, this is a really rich and very active living area where we've got lots of microorganisms. You're going to meet some of them later, which is fabulous. Those microbes and all the other animals and also all the plants are having a much more dominant effect. And they're really changing these fundamental soil layers and changing the texture and the way that they look, and so on. So you can see these quite distinct layers in many soils. And you don't need to know very much about them, but the really key message to take away from this is that you don't want to mix topsoil and subsoil together. Topsoil has taken hundreds, and actually in many cases thousands and hundreds of thousands of years to become rich and active. It's extremely precious and valuable stuff. So if we are mixing the topsoil and the subsoil, we're actually setting back evolution. And can take a long time to recover from that. So it's a really good idea to separate topsoil and subsoil if you're doing any building work or any excavation work at your property. Don't mix them together. I also need to say, for people who are on new housing estates, often they've sold you topsoil. So it's a bit of a bummer, but you might actually have to buy topsoil back in. You can tell it's subsoil if it's often really poor, and that will make more sense at the end of the session when we've looked at healthy soil a bit longer. Often it's, depending on whether you're on a clay or a sand base, you get a very extreme effect of sand or clay. And often when they're building, they don't want it there when they put the house in. So they scrape the site and sell it to a landscaping supplier. And then they put a very thin layer of topsoil back on, just enough so they can get away with some landscaping plants so that you buy the house. But just be aware of that. You may not have a lot of topsoil in some new areas. Now I can see a few questions around how deep these layers are and the average depths. And I'm afraid there is no average. It really varies depending on where you are. Another reason why you might not have much topsoil is because your area used to be a gold mining area. And we have lots of those in central Victoria, where the topsoil is literally stripped off whole landscapes and washed away. And people there are really starting with a subsoil layer that they need to improve. So we can improve it. And we can do that surprisingly fast because we can intervene more quickly than evolution. But just keep that in mind, that we don't want to be mixing these layers together, and we want to treat topsoil as the precious and rare stuff that it is. Jenny's from Ballarat, yes, very much a gold mining town. All right, so let's get a little bit deeper into the soil and find out a bit more about what it is. And when people think about soil, often you've never thought about what's in it, what makes up this stuff that we're holding in our hands. And it helps to know what's in it so that we can help look after it. And the parts that I was just talking about, the sand and the silt and the clay, make up what we call the mineral particles of the soil. And these are around 45% in a healthy soil. They will be there unless that soil is blown away or washed away. They tend to stay there as the base. But the other parts of the soil are the ones which are most important for fertility, but are often missing when we encounter poor soils. So these are firstly air and other oxygen and other gases. There's lots of gas exchange. Plants also need air around their roots. And so that crumbly structure that we looked at before is how we know, yes, there's air in this soil and we've got that balance. We'll talk about how to add some air and decompact soils in a minute. Just keep in mind at this stage that air is absolutely essential for healthy soil. Another important factor is water. And when we meet some of the life in soils, we'll find out, of course, that just like us, they need water to stay alive. So if the soil is completely dry, those things won't be able to live. Our plants won't be able to live, of course. So water is essential to healthy, fertile soil. And if you like, the line between the air and the water in this graph is a bit of a blurry one. So if a soil has dried out completely, there'll be very little water and a lot of air if there's good structure still. If the soil has flooded, we've had heavy rains, all of those air pockets will be full of water. And that's also a problem, of course, for our soil. So think of that line as swinging around a little bit, and one that we try and manage as gardeners to keep it in balance as much as possible. Now, the final wedge in here is organic matter. And it's got organic matter at only 5%. So you could be tempted to think, oh, well, as long as we've got our mineral particles, air and water, our soil is on track. And that would absolutely not be the case, because organic matter is the secret to healthy, fertile soil. This is the living component. It is anything that has lived before and also possibly is still alive. So in this graph, they have the organisms. These are living creatures, and they could be very large ones like worms and beetles that you can see, or they could be so tiny that you need a very powerful magnifying glass or a microscope to see them. So they're alive and they're maybe 10%, let's say. The roots of plants count as organic matter, very valuable source. We're going to come back to them, at 10%. And then the other 80% roughly is what we call humus, which is not to be confused with hummus, which is like an obligatory joke that you have to make when you're teaching soil. So please excuse me for that. Now, humus is all those things that used to live that have been broken down by living forces, like by microbes, by fungi, by worms, and it's been concentrated and reduced. So humus is gold. It's concentrated sunshine and life. And this is the stuff that is that lovely, rich, dark colour. And it's the reason why those two side-by-side soil samples that I showed you, one of them was very dark. That's because it had a lot of humus in there. So humus, it's a fancy word and you don't need to kind of remember it, but just remember the key message here is that living stuff is so important to plant health. A healthy soil needs at least 5% organic matter. Mine is around about the 15% mark, which is getting very high. It's not a bad thing, but you only need a little bit to really kickstart a healthy soil. One more final point just on this chart as well. I hear a lot of people who are getting started gardening and they talk about compost and soil interchangeably. And I can understand why, because they do look superficially similar. But I just want to point out that compost fits into the category of humus. Compost is basically, it's almost pure humus when it's properly matured. So think of compost as being a small subset of your soil, and you don't need very much of it to make your soil healthy. And it's not the same thing as soil because compost doesn't usually have many mineral particles inside it. So I hope that makes sense, and do feel free to pop any clarifying questions and things in the chat window as we go forward. Right, so now we're going to go into some of those mineral particles a little bit further, and I'm going to step you through after that a process for bringing soil back to fertility that will involve air and water and organic matter as well. Have a look at the picture now that's at the bottom of your screen and some of the different sizes of these particles. And what's interesting, fascinating even, is clay is so small that you can't even see it at the scale that this picture is in. It turns out when you look down a microscope, it's actually impossible to tell the difference between clay and some types of bacteria. That's how small clay is. Sand, on the other hand, is absolutely giant. Now, if your soil has a lot of clay or a lot of sand, it will have quite different characteristics. So I think at this stage, I might start a little whiteboard with you and we will work out some of these characteristics together because they are fairly intuitive. So let's have clay over here and sand, further sand over here. And let's pop in the centre. Firstly, drainage. Now you tell me in the chat window, if you can, what is the drainage like in clay soil compared to sandy soil? It's very poor. So we've got poor drainage. It's very hard for water to move through it. And we've got very good, started another one. Very good drainage in the sandy soil. What about nutrient holding capacity? What is that like in clay soil? Clay is, these text bubbles. Clay has very good nutrient holding capacity. And this actually relates to the surface area because nutrients in soil get held chemically on the outside of the particles. Now, just to try and imagine how this works, if you imagine that you've got a bucket that's full of marbles and that's your clay. And then you've got a bucket that's full of tennis balls, and that's your sand. Think about which one has the most total surface area on the outside of the balls. Feel free to have a guess at that in the chat window if you're feeling brave. Yeah, so clay and the marbles, as Fran and Michael have correctly deduced, they have a much greater surface area because they're very small and a lot more of them can fit into the area. So that translates as being much better nutrient holding capacity. And that's why the clay is so good in that respect. Sand, on the other hand, is giant and it's difficult for it to hang on to a lot of nutrients for that reason. Okay, what else should we look at? Let's look at root penetration. So if you're a root and you're trying to get nice and deep into the soil, would you prefer to be in clay or in sand? Yeah, sand. So thank you to Mary and Rebecca. So sand tends to have roots getting a good go. Oh, sorry, trying to do too many things at once here. Root penetration is good. Oh, now it won't let me delete it. That's not fair. Let's try that again down here. Root penetration is good, and not always, but it can be poor in the clay soil if that clay isn't well structured. All right, let's try water holding capacity as well. Which one can hold the most water? Clay, says Nadine and Emily. Yes. So clay can hang on to a lot of water. It can actually hold it so tightly that sometimes plants have trouble accessing it, but that's another issue. And then for the sand, we have low water holding capacity. So that can be a real problem, particularly in the drought-prone parts of southeastern Australia. I see Tara says, clay is excellent if the water can get into it, and that's absolutely right, and we're going to come back to how to make that happen. So that's a bit of a sketch out of the two extremes of soil texture, and there is actually another type that fits in the middle. Of course, we have silt, which has a few characteristics of each. We'll look at those in a minute. But there's a type of soil that we call a loam, and a loam is I guess the holy grail of soil types. It has a nice balance of all of these characteristics. It's like the Goldilocks zone. So it's lovely if you can find a loam or create a loam. But just know that we can actually work with even quite extreme clay or quite extreme sand and still have some good results. So I'm going to get out of that whiteboard and I'm going to get back into my slides and we'll start looking at some of these different soil types. Now at this stage, some of you will already know whether you're working with an extreme clay or an extreme sand or something in between. If you're not sure, there are some ways that we can test that. And I'll pause actually here and just show you. I'm going to show you some very daggy hand-drawn cartoons and use an analogy of a shop, because there are lots of different parts of soil and it can be confusing to understand how they all relate to each other. So I'm going to build on this throughout the session. And for now, I'd like you to know that these soil textures, the clay, the silt, the sand, these mineral particles are about, in this analogy, similar to the building materials that we would build a shop from. I will come back to that, I promise. Okay, so this is a bit of a fancy soil texture chart that shows some of the different soil types that are out there. And I'm going to send you some soil testing notes, or maybe actually Becca's already sent them, or you'll get them straight after the session. And you're going to be able to do a test to work out where you fit in here. This is a really simple test. It's not like highly accurate, but it's probably accurate enough for most home gardeners. And there is an alternative test which is a bit more accurate, but involves a bit more experience. And that test is about handling soil and comparing what you can feel to a little chart. I'm just going to explain the jar test now though, because it's probably the simplest one that you can do at home without any experience. And in this test, we fill our jar up any kind of sealed jar with about 2/3 soil, and then top that jar up with water, leaving a little bit of air at the top as headspace. And then we're going to shake that jar up, really, really shake it and try and break apart any clumps of soil that are in there. And then we're going to start a timer and quickly put that jar down on a surface to rest. And because these particles are different sizes, the heaviest ones are the larger ones, things like sand, and they're going to settle out first, followed by the silt, which is in between the clay and the sand, and then the clay. And in fact, the clay may take a couple of days to settle out, so you can't read this one immediately. It's difficult to show you this in photos, but I wonder if some of you can see it. There are actually 3 layers in this jar, but just to help you, I've drawn lines because it's difficult to photograph clearly for you. From here, what we could do is measure the jar, measure all the soil layers, and then work out what percentage we have of each of these. And then we can go back to our texture chart, which will also be in those notes, and we can actually work out where the soil sits. So let's say, I'm grabbing my pen so I can highlight this for you. Let's say we had 40% sand. I'm just going to draw that line from the sand. And let's say we had 20% silt. I'm just following those little directional arrows to know which way to draw. And then we had, say, 40% clay. Okay, so we work out where these points touch, and that will tell us which soil type we have at home. Now, I've actually gone just between, it's probably not the best example. If I had, say, 35% clay, I'm making a bit of a mess for you. Anyway, you can be on the line between 2 soil types, that's possible. In any case, you can see here that we're on the line between clay and clay loam. Now, the question is, does that matter? And the answer is sometimes, but not always. And we'll talk about those different soil types in a minute. But this is a simple way of getting a classification on your soil without much experience. Now, I'd like you to look at this chart and have a look at the way that all of these shapes are distributed, and tell me what's interesting about the pattern. What do you notice about the way all of these words are divided in the triangle? And there's always radio silence when I ask this with an online group now, so I'm not necessarily expecting any answers. Rebecca says they all overlap. Yes, so there are definitely areas where you've got patches of sand all kind of close together. Yep. I guess the thing that I wanted to highlight here is the dominance of clay. So if you look at all the clay words in here, you'll see if we look at the clay side, anything above about 25% clay in your soil gives you a clay soil. So you experience a clay, even if it's only 25% clay. So clay is very dominant, and it doesn't take much of it in a soil to start really impacting the way that that soil behaves. Also, just coming back to what I was saying about loams, notice that loams are centred between all of those soil types because, as I said before, they have a balance of all of those different mineral particles. Now, when I say clay is dominant, that has a bit of implication for us. If you have an extremely sandy soil, like a sandpit, like that sample that I showed you on the left-hand side earlier, it means that we can actually add a bit of clay to rebalance it. And actually, that's one of the things that I had done to improve that soil and get to that lovely picture on the right-hand side. So we can add a little bit of clay to a sandy soil, but we can't really, on a large scale, add sand to a clay soil because you just need so much of it to get a result, as you can kind of see with this chart. So you could try it on a pot scale or on one garden bed scale, but if you have a really clay soil, we need different options for dealing with it. Okay, so I wanted to say, if you've got that really sandy soil, there is something that you can add to improve it, and I'm going to type that for you in the chat window. It's called bentonite clay, and this has just become widely commercially available in Victoria at nurseries. However, before it was commercially available, I actually added, this will shock some of you, I know, clumping cat litter, which is pure bentonite clay if you get the absolute rock bottom cheapest home brand option off the shelf in your local shop. And bentonite is what they use to fix leaking dams. It's an incredibly absorbent, swelling clay, and it's powerful stuff. It can hold 5, and I've read up to 20 times its own weight in water. So just imagine how much water holding capacity and nutrient holding capacity you are adding to a sandy soil if you add some of that. And Joe has asked what ratio, and it's incredibly important that you start small and don't overdo it, because you could very, very easily create a boggy, muddy mess out of a sandpit soil if you add too much. So I would always recommend you follow packet directions, because there might be some variations in different bentonite clays. But I added half a kilo per square metre to my soil initially, and then added a little bit more after that. And it will take a little while to become integrated into your soil structure. So at first you'll see chunks of clay, and then 18 months later, they will all just become part of the crumb structure. You can either turn it into a slurry and water that in. I'm just reading Joe's question. Or you can dig it in, and dig it in is probably the better way, unless you've got some existing plants that you're trying to work around. So just keep in mind, you can always add a bit more, but you can't take it out once it's in there. So go really gently with bentonite, and only use it if you've got an extreme sand problem. But for those soil types, this is a game changer, and it's really worth everybody being aware of it, because a lot of landscaping soils now do end up being extremely sandy and difficult to work with without some sort of balancing. Now, if you've got a clay soil, you have got an option of adding something called gypsum. But gypsum will only work for you if you have a particular type of clay that is dispersive, as in it starts to disperse if you put it in water. So there's a test that you can do where you put a little crumb of soil in some water and leave it there and see what happens. So if your soil starts to get a halo around it, like in the moderate and severe groups, then gypsum will help your soil. Gypsum chemically adjusts your soil so that it crumbs together, and you create those little crumbs out of an otherwise solid block of clay. So yes, so those are the things that you can try with clay soil. If your clay isn't dispersive, then gypsum won't work. So don't waste your money on it. The good news though is that whether you've got sandy soil or clay soil, you can always add compost and other forms of organic matter, and they will bring that structure back into balance for you, no matter what type of soil you have. So I would always try adding compost, and if that's not enough, then I would look to some of these other measures to adjust that texture. Okay, now I realise I just used texture and structure interchangeably then, and I didn't mean to, because they are different. The texture relates to the balance of sand, silt and clay in your soil. The structure relates to how they look. Are they crumbly? Are they lacking in any kind of form? Are they a solid mass like the hand on the right hand side here? Or are they slipping through your fingers like the sandpit that we saw before? So structure is about the way that those building materials are put together. And ideally, as gardeners, we want them in little crumbs. That's where the oxygen and the water and the roots and the biology can interact most easily. And this is a lovely diagram. You can see the pore spaces and the way that these grains of sand and other smaller grains of silt and clay are bound together in crumbs. Those crumbs form actually because bacteria and fungi bind those soil particles together, which is quite exciting stuff. And we'll, as I said, meet some of them later in the session. But there are ways that we can kickstart some structural changes if we want to get air and water into soils quickly. Now, I'm mostly talking about with more clay soils here, because sandy soil sometimes is difficult to do these sorts of changes. But we're going to look at an example of how you might add some of that structure into a soil. Now, I'm going to hit play on a video and I won't talk over it because that sometimes makes the quality go down for you. You don't need sound on this video, by the way, if you're wondering. Okay, so the tool that she's using there is called a broad fork. Don't be put off, you don't need one of these at home. You can use exactly that same levering action with a normal garden fork. And in fact, for people who want to go back and watch the last session that we did, there's a recording of that, and there's another video in there just using a standard garden fork to achieve the same thing. Now, I was just hoping to leave it a little bit further. I might skip forward. But she actually puts her hand into the soil. I think it's this bit. Let's have a look. Right, there we go. So check that out, how deep she can put her hand into that soil, and imagine how much more you prefer to be trying to get your roots down into a soil that's loose and open like this one, as opposed to a hard ground that you saw before. Just physically levering the soil open like this is enough for a lot of heavier soils to just kickstart this process of opening them up and improving that structure. And then I tend to do this after I've cleared the beds and before I plant each annual vegetable crop. I very rarely need to do this now with any of my fruit trees or perennial areas, because that soil is not being disturbed, and earthworms and other soil life, and also roots as they grow and then die, will create these lovely crumbs and channels in the soil. So you don't always need to do this, but particularly starting new gardens that haven't been well managed, this is a lovely trick to have up your sleeve to work with them. All right, so back to the soil shop. We have a long way to go, so I better speed up a little bit. The building layout is like the soil structure. And so I've added some shelves in there, and by creating those crumbs, you're just allowing lovely space between these aisles for the plants and the roots to roam down. Okay, the next one we're going to look at is soil pH. Now, soil pH is a measure of the acidity or the alkalinity of your soil. And you'd be familiar with some of the types of things that are acidic, like lemons or vinegar, of course, and some of the things that are alkaline, like soap or drain cleaner. Now, hopefully we don't get that acidic or alkaline in our soil. Our soils range usually from somewhere between 4 up to maybe an extreme of 10. But there are consequences if your soil is an extreme on either side. It's also worth knowing that this scale is not a gentle linear scale. This is a logarithmic scale. So every number is 10 times more acidic or alkaline than the number next door. So what can seem like quite a small change from our perspective can be a really significant change for the plants. And the reason why it matters, if I just swap to my next slide, is that nutrients that plants need can become more or less available depending on the pH. So what you can see in this photograph is a band that's around 7. And this band is, 7 is neutral, I should say. And this is the band where we have most availability of the sorts of nutrients that plants need. Now, I know this one actually says 6.2 to 7.3, and I'd say I usually say 6.5 to 7.5. So there's a little bit of variance between books and what you read here, but the key thing is that they're focused around that neutral pH 7. If we start to get outside of those ranges, some of the really key nutrients like your nitrogen, phosphorus, potassium, you can see with the red sections, they become rapidly unavailable. So we get nutrient deficiencies. We can also have other things opening up, particularly heavy metals. So we start to get toxic amounts of some things becoming available. Now, for those of you who were in the last session, we talked a lot about soil contamination. And I'm just reminding people that if we move into the acidic end of the pH spectrum, dangerous heavy metals, including lead, start to become a lot more available to our plants. So for that reason alone, it's a really good idea to know your soil pH in urban areas and to keep it around that neutral mark. I'll talk about how to adjust soil. I also want to remind you that you can grow to what your pH is, and that will be the only option you have on a larger scale. So if you do have naturally occurring acidic soil, and you've not got a major lead issue, you're a blueberry farmer. Congratulations. Blueberries is one of the common food crops that actually thrives around the pH 5 mark. Most other things will not be happy in soil that's that acidic. So you can learn to adjust your designs to whatever soil pH you've got. Well, firstly, how do you know what soil pH you've got? The answer is with a pH test kit, which I'm going to hold one up to my little video feed now. These are about $25 and they're available from all good nurseries and hardware stores. And this one is a colour check kit. So you'll follow the instructions on the packet and you'll compare the colour of your sample to the colour chart that's provided. The photograph on the screen is around about a 7.5. And yes, I know that's a little bit subtle. It's easier to see in daylight, but that's how you'll tell what your soil pH is. So that's the way I'd recommend. I would not recommend any kind of probe that you put in the soil, which is another version they sell commonly. Those are very inaccurate in my experience. So I really strongly recommend that you use a colour test kit for pH testing at home. So more good news. Compost, no matter what soil pH you have, good finished mature compost is actually going to buffer your pH back towards that neutral level. So that's great news for us. What I can't tell you though, and maybe someone out there listening does know the answer to this, in which case please let us know. I don't know how far that effect will happen from. So I would say if your pH is 7.5 and you want it to be 7, add compost and hopefully it'll come back to 7. If your pH is 8.5, I don't think compost will be strong enough to achieve that neutral effect. So you will need to look to other amendments if you need to change the soil pH beyond, say, 0.5 or 1 point. So there are options for you here. And I often hear with home gardeners, lots of people talking about, say, adding pine needles if you want to make your soil more acidic, or adding coffee grounds, for example. And I hear people talking about adding wood ash to make their soil slightly more alkaline. And I've used the wood ash and that seems to have worked well. What I can't stake my name on is coffee grounds or pine needles, acidifying your soil enough to have a strong effect. So I'm not going to say don't try them, especially if you've got those materials available, but I do want to give you what I would use as a professional to have guaranteed results, but while still encouraging you to experiment with what you've got access to at home. So if your soil is too acidic, you can add garden lime to it. And what I won't do is give you the ratios or the amounts, because that will actually depend on whether you have sandy soil or clay soil or something in between. So again, just look at the packet and it will have all those directions on there for you. One of the mistakes that I made initially is thinking that dolomite was a better form of lime. And it's actually not. It just contains magnesium as well. And the question is, does your soil need magnesium? And if it doesn't, or if you're not sure, you are a lot better adding lime, because we don't actually want to change the balance that's in soil by randomly adding something unless that we know we need it. Okay, on the other end, we've got elemental sulfur, and this is what we would add if you had an extremely alkaline soil. Say we're talking maybe 8.5 and above. It's a bright yellow powder. It's a little bit intimidating, but it is safe as long as you don't breathe it in. And elemental sulfur actually works in conjunction with soil life. So it will take a few months to have an effect, but it will successfully lower the pH back down again. So that's the nuts and bolts, very fast overview of adjusting soil pH. And I will need to leave it there just in the interest of time, but I'm very happy to come back to some of these topics in questions during the break or later on. And in our soil shop analogy, I have put the pH as like the opening hours in the supermarket, because if the pH is not right, the nutrients or the products can be there on the shelf, but the plants can't access them because the pH is out of whack. So think of it as like a range that opens up access to your soil shop. All right, now Beck, I'm just going to check in if there's any questions that we need to follow up on at this stage before we move on.
Just checking you can hear me.
Yes.
Yeah, we do have a few. Look, I'll just chuck a couple out there. So one from Mary about compost. So should you dig in compost to a clay soil or leave it on top?
Oh, great. Okay, yeah, so we're coming to organic matter, and I did talk a lot about it in our last session as well, Mary, so you might want to go back to that video and have a look at that as well. You can do either, but I personally will just, I like to say tickle it into the top few inches of your soil, and that just protects it from the UV sun beating down on it, which can oxidize some of the good things in compost, and I guess makes it easier for the roots to get fast access to. But both of those things will work. So it's a little bit of personal preference.
Yeah. A few questions about topsoil. So one from Catherine, if you don't have topsoil and don't want to buy it, can you create this with compost, branches, leaves, that kind of thing?
Yes, so branches and leaves are ingredients of a compost. So you can use them to make compost, and you can use compost to improve subsoil. That might be a slow process though, because you're starting from a pretty low base with subsoil. So you can have a go at it if resources are very limited. If you want to get started quickly and know that you'll have good results, then I'd think about buying some topsoil in. I wouldn't be deterred from having a go though in areas where I'm planting trees. But for annual vegetables, it might be a bit of a slow start for you. Yeah.
One question about differentiating between garden soil and construction soil. How do you do
that? I mean, it's all soil. Soil does get very damaged through the process of construction though. I'm not totally clear on what the question is. So maybe if you can clarify that one a little bit more for us, we can come back to it. Yeah.
Tara asks, Are you only wanting to help balance out your topsoil, or would you temporarily remove your topsoil and still try to add some gypsum, for example, to the next level down?
Yeah, it's a tough question, particularly when you've already got things growing in soil. So if there's nothing there and you've got, you've got a particularly heavy clay, I might be tempted to do that. But if you've already got things there, just work from the top, and I think it is okay. Yeah. I have loosened the soil with a garden fork and added gypsum where I've had the opportunity to scrape away topsoil. It's pretty hard work though, and it's difficult on a larger scale. So you've got to just make that judgment yourself on what's worthwhile.
Joe's asked a question about pH. So she's tested her soil and it came out about 8.5. Is that an issue?
Yeah, compost, it often tests quite alkaline when it's not fully matured yet. When it has sat for a while and fully processed, which can take a few weeks to several months, depending on the method that you use, it should come back to around neutral. But it's a great point, Joe, because a lot of compost that is sold to people hasn't gone through those maturing phases yet and still can be quite alkaline. Unless you've got a major existing alkaline soil problem in the area that you're adding compost to, I would just add the compost knowing that it is going to come back around the neutral mark. So that wouldn't deter me from actually applying it to my soil unless there was already a big issue with the pH in the soil.
Maybe just one more from Jan, which is earlier on. Can roots of trees anchor better in clay than in sand?
Oh, it's a really good question. And I don't know the answer to that for sure. So I'd prefer not to just come up with an answer for you. So there could be pros and cons of both clay and sand. So if anyone out there does know the answer to that, pop it in the chat window, but I prefer not to comment where I don't know the answer for sure. Yeah. Okay, Beck, are we moving on?
Yeah, sure, let's move on.
All right, let's move on. We'll come back if there's other hanging questions, and some things I think will be covered later on as well. All right. Okay, let's go through organic matter and then we'll have that short break. Organic matter I've already told you about. It's the magic that happens in soil. It refers to anything that was living or maybe is still living. So that could be leaves, twigs, roots, manure, food scraps, wood chips, dead animals, all of those things. Also roots and living animals get encompassed in the organic matter category as well. Now, as gardeners, we usually apply it in the form of compost, but there are some other things as well, like green manures, for example. Now, green manures are a crop that you grow not to eat or to harvest even, but to improve the fertility of your soil. So they're green plants and they take the place of a traditional manure. So we call them green manures. And a green manure can actually be any plant, which is exciting because all plants in some ways improve soil fertility. But there are some special plants called legumes. That's a family group that includes peas and beans. And legumes often, in fact mostly, have a special ability to fix nitrogen from the air in the soil in a form that plants can access. And they actually do that in partnership with a bacteria that lives inside their root system. It's just incredible stuff. So the photograph that you can see with all those little white bits on it is the bottom of a broad bean plant at my place. And those little white things are called nodules. And they're the little homes that the plant makes for its microbial friends. And so those really special bacteria live in there, and they're able to take the large proportion of nitrogen that's in the air out and then turn it into a form of nitrogen the plants can use. So these particular plants supercharge the amount of nutrients that will be available to the next crop. If you do grow a green manure crop, just be aware though that the plants are getting all that extra nitrogen for a reason, and that's to put it into their own seeds to create really strong seedlings. And if we go and harvest the peas or the beans, we're actually removing a lot of the nitrogen that would have been able to go into the soil. So you might just want to have peas and beans, which is fine. But if you are growing it intentionally to improve your soil, the advice is to actually cut these plants down when they start to flower, which is the point where the maximum amount of nitrogen will have been formed. So you can either pull them up and chop them up and compost them and then put the compost in, which is the high effort way of doing things, or you can be really lazy and just cut the tops off and leave the roots in the ground. You can chop the tops off and cut them up and leave them on the surface as mulch, and that's what I do. Some people will till them into the ground, so they'll actually bury the plant. And all of those ways are valid ways of doing it. It's just important to understand that principle about when to cut off the lifespan of the plant for maximum effect. Any plant that's green or lush, though, is building organic matter that will then benefit the soil. So even weeds can be a form of green manure. You just don't want to obviously let them spread if they're a very spreading type of weed that will then start to propagate aggressively. But with that in mind, that principle, you can turn lots of things into green manures and start cycling them around to build healthy soil. Mulch is also an organic matter source, and we'll come to that in just a minute. So what I need to say about organic matter is that plants know how to do this, and plants build up their own if we keep out of the way. So I've got some photos to prove that for you. Here is my persimmon tree, or the leaves rather of my persimmon tree, as they lie on the ground about this time of year. And if I leave them there rather than get out there and rake them all up, what happens by the middle of winter is they're all starting to break down. And I think you can see my mouse. I've got a bird that's come in, which is awesome because it's left a deposit. So I'm also accumulating nutrient in that way as well. And of course, there's a lot of life in here, and we're starting to really build some great diversity in the garden just by creating habitat. And then here is the result, and this is springtime, and you can see most of those leaves have actually broken down by now, and I just pulled them away and quickly took a photo, and you can see, I don't know how many worms you can spot in there. I spot about 5 of them. And that's 5 just in an area the size of my hand. And I think you can see the little crumbs that those worms have left and some of the channels that they're starting to form. So that's the magic that can happen if we just get out of the way. But humans are very, very good at interfering, unfortunately. So one of the things I need to encourage today is that if you've got a green bin, you start thinking twice about what you put in that green bin, because the green bin is actually stealing your plant's food, and you're actually paying twice with a green bin. You're paying to have it taken away, and then you'll have to pay to bring stuff back in to replace what you sent off. So as much as you possibly can, keep your organic matter on site and keep it cycling around and around. And I can see your question about weeds, Georgina, and I'm just keeping an eye on the clock. So I'm hoping that that might be one that we can come back to, and I'll ask Beck to take a note of that. Okay, now, just before I move on from this, the key, most important point here that we all need to take away is that organic matter has to be continually cycled. It's not a once-off addition. It's actually how plants continue to be fed and grow their tissues. When we're harvesting plants, we're removing organic matter, and it just needs to be constantly added. So, for example, with compost, I would add about 1 inch or 2.5 centimetres roughly across the entire surface of the annual vegetable beds every time I'm planting. And I don't really keep tabs on how much my fruit trees get because I'm just constantly chucking leaves and stuff under them all the time. But, you know, it's probably about the same. They don't need as much as vegetables, but it doesn't hurt them either. So constantly think about how do we cycle this organic matter around, get it back into the soil where it belongs so that it can then give us healthy plants. All right. So I will move on now. And I'll finish off this section just by saying organic matter does everything in your shop. It means you get more and you get better space. There's longer opening hours, or it's more likely to be within the opening hours when you show up. There are better shelves, the layout's better, so that as in the structure has improved so you can get around more easily. There are more products on the shelf, which, spoiler alert, is about the nutrients. There are more employees there to help you, which is pretty cool. So you want organic matter in your soil food shop. And this is the point where I think we'll pause for a 5-minute break. When we come back, we're going to start meeting some of the employees of your shop. And this is where things get really, really exciting. So I do hope you'll come back for us at about 3:15. If you do want to stay, I'm happy to take some more questions in the next 5 minutes, but I also just want to leave a break where we won't cover any more content so that people can get up and have a stretch and refill their cups of tea or coffee.
We'll just pause our recording now as well.
Okay, lovely. Are we ready to go?
Yeah, I just started the recording again.
Lovely. All right, let's jump back into those slides. I don't get a lot of feedback in these sessions, so it's hard for me to know how well this is landing with you. So do give us any feedback that you need to in the chat window if something's not quite working from your end, and I'll do my best to adapt. All right, so we're back in the soil shop, and as promised, we're going to meet some of the employees of the shop. I'm just going to skip that one for now. Whoop. And to do this, I thought I would play you a little video. Okay, so let's give this a go.
The soil food web begins just like that of the world above, with plants. A leaf falling to the ground may not seem a big or important event, but it provides food for an astonishing array of microscopic life. Bacterial cells and fungal hyphae break down the leaf and absorb nutrients, yet these are only the first to take advantage. Tiny nematode worms come to graze on the growing microbes, while a pair of springtails samples the fungus. Springtails are 6-legged animals with diverse appearances. They love fungus, but will not pass up a nutritious nematode. Meanwhile, an aurabatid mite has just arrived. It feeds on the dead leaf and on the bacteria covering it like jam. When a predatory mesostigmatid mite appears, the springtails flee for the surface, but the nematodes are not so quick, and the mite drinks them dry. On the soil surface, other predators await. A dipleuron strikes, and the springtail reveals how it got its name. A lever-like appendage on its abdomen allows the springtail to jump up to 6 inches to escape danger. Yet with its 6 quick legs and sensitive antennae, the dipleuron is a tenacious hunter, which can now claim its meal. These are just a few of the many creatures that call the soil home, living their millions of little lives right beneath our feet.
I love that little video, and I can't help but share it with you. I thought you might actually like to see some real videos of things in the soil though. So I've actually pulled up 2 videos that show you what it looks like underneath a microscope. So let's see if I can make this play for you. Oh, sorry, done something. But can you see a video?
You can see the video. Yeah.
I'm going to turn the sound off these ones. Okay, so this is what bacteria look like. Oh gosh, sorry, a bit harder than I expected. This is what bacteria look like down a microscope of about 400 magnification. There's little rod-shaped ones, which could be a lactobacilli in there. There's little circular dots, which could be cocci bacteria. They could also be clay particles, and we don't know the difference, as I said, because clay is so small. And there's also these chunks in here, and these could be, or these are chunks of organic matter. That's what your humus looks like underneath a microscope. So that's the bacteria, but there's also many more exciting things that live in your soil. And I've got another video here to share with you. Looks like I have to close my bacterial lens so I can show you this one. So we're going to go a level up this time and look at the things that eat bacteria. And let's see if I can make that a bit bigger for you. And turn the sound off and hit play. Okay, so I'm pausing there. So firstly, the ones that are whizzing around that you can't see because they're a bit blurry and out of focus, those are the ciliates. And this is a type of protozoa that eats bacteria and fungi. They're like the racing car drivers of the soil. They move really, really quickly. Then we've also got flagellates in this image, which are the ones that are little oval shapes that have a tail that are kind of bumbling through the soil. So I'll play some of them for you. And finally, you can see a bit of a blob that's moving. And I always thought that amoebas were just these things that they had in kids' cartoons, but it turns out they're actually real and they live in the soil and they're all around you all the time. And so this blob that is moving through the soil is an amoeba, and it moves by creating pseudophyte, pseudopods, and it pushes part of its form out and creates a little thing that it can use to push its way through the soil, and then creates another one and another one and another one. So it's like this blob of slime that's moving through the soil all the time. And then the thing that it's next to is probably a strand of fungi. So I'll play it again. I don't know if you can see my mouse, but I'm putting my mouse around it if you can. That little strand there is what a piece of fungi looks like in the soil. So it's all very exciting. You don't need to know any of this, of course. You just need to know that the soil is alive. And I guess one of the key messages from this part of the session is that every time you step on fertile, healthy soil, I'd like you to hear billions of little screams coming back at you from all the life that's under your feet. So they are there, they're alive, they need air, they need water, and they don't need some big, heavy human crushing them from the soil surface with their boots. So one of the things about healthy soil is you want to make sure that you've got nice pathways, so you don't need to step on any of your beds to do work, and preferably not to harvest either. The occasional step won't hurt, but your feet really will compact that soil and undo a lot of that good work that we've talked about in terms of structure. So do your best to put paths in and stick to them, and you'll keep these soil life humming and happy. There are a couple of other steps as well that I wanted to share with you. Oh, firstly, Ashley, I've got a little diagram here. Again, you don't need to remember any of this, but know that there's a web of life, and everything eats everything else, or at least there's lots of interconnections between them, and everything poos out something slightly more complicated and concentrated than the last. And that's how you go from having a leaf falling on the surface to having this really concentrated stuff called humus, which is ready to be reabsorbed by plants. So we can see some things in the soil food web, like your arthropods. We can see little mites sometimes, and we can certainly see birds and animals that eat them and interact with them. But most of the life in the soil is microscopic. And nematodes are tiny little worms, but you can only see them with a microscope. And most of them are beneficial. So they're actually helping plants out. There are some obviously pathogenic fungi and bacteria and nematodes that people talk about as a problem, but there are also good ones that eat the bad ones, and there's just a web of life happening all the time under our feet. You can't see them without a microscope, but you can certainly see the effects of them. I wanted to show you this picture of a wine barrel that had been filled with soil that I looked after for about 5 years. And after 5 years, after I took this photo, I could kick my foot through that barrel. It had just been completely eaten out by fungi. So they have a real effect. And healthy soil that's full of billions of these creatures is actually digesting, and soil becomes like the stomach of your plants. Plants can't move around, and they need the soil to feed them. And the soil is what digests all this fresh stuff that we put on the surface and turns it back into plant food all over again. So to look after our soil food web, there's a few really simple things. Try not to manipulate the soil more than is necessary. And so I think forking is a lovely, gentle way of improving structure. I try not to do a lot of digging unless it's necessary. Where possible, use perennial plants. And most of our common loved vegetables are annuals, but things like fruit trees and berries and other more permanent shrubs are going to help stabilise the soil food web because you're not disturbing them every 6 months to replant. Keep your soil healthy by adding organic matter and water and mulch and doing everything we're talking about in this session. And then it kind of goes without saying, but try to avoid any synthetic chemicals because most of them have really quite disastrous effects on soil food web. And that inhibits then all the roles that those creatures play in keeping your plants healthy. And as I said, finally, don't step on those garden beds, please, and try and imagine all those millions of screens whenever you do, and that'll keep you motivated to stay off them. Yeah, so soil food web plays this incredible role in plant health and in plant nutrition. We're only really starting to understand the effect and all of these interlinkages, but we do know, for example, that a plant more often than not has a symbiotic relationship with a fungus, and in this relationship the plant can say, hey fungi, I need some molybdenum, which is a little micronutrient, and the fungus can go and find it and bring it back to the plant through the network of fungal hyphae that it forms under the soil. So it's really just incredible stuff. Fungi are like an internet that can connect plants together, and they're like a railroad track where they can be bringing things in and out well beyond what the plant's own root system could accomplish. And the reason why they're so keen to help the plant is because the plant is literally their sugar daddy, literally giving them sugars out their root system. Plants, when they photosynthesize, they as much as 80% of what they're able to photosynthesize, they pump out their roots as proteins, carbohydrates, and sugars. And those things then feed this incredible army of life in the soil and create that symbiotic relationship. So the plant gets protection from diseases, pathogens, it gets extra nutrients, it gets sometimes a linkage with other plants in the nearby area, and then for its part, the soil food web starts to get all those sugars coming through from the plant root system. And yeah, so I might stop there because that's more complicated than a home gardener needs. But this is just such an exciting and interesting area. And the more I learn about it, the more overwhelmed I am by the complexity of what's happening under our feet in this soil all the time. Okay, so we're going to go back now to the soil shop, and I'm going to talk about water. And in our soil food shop, we've got, well, firstly, the soil food web as employees. I kind of skipped over them. And this little character here does not have reindeer antlers or crazy hair. These are intended to be little fungal hyphae, the strands of fungus that you saw in that microscope video. That's how we know. And it's also very small, and you'll see that when we put in the rest of the picture. It's stacking the shelves because that's one of the roles that they play in helping plants to get nutrients. Moving along now to water, which in this analogy is like the shopping basket. It's a bit of an odd one, I know, and of course water does lots and lots of different things in soil. But one thing it does do that's important for plants is actually dissolves nutrients so that plants can drink them in through their root system. So plants actually need water, not just for water itself, but because water is able to dissolve nutrients. So it's possible that you could have all the nutrients in the soil, but a plant that is unable to access them because the soil moisture is not sufficient. Just like in the same way, they could all be there, but if the pH is a little bit wrong, the plant might not be able to access them or access enough of them. Now, for water, I'm going to point you towards the previous session that we ran where we actually covered water, how to check your soil moisture, how to water efficiently, and for best results. We covered that in enough detail, I think, there. And I actually normally run this session as a 3-hour session, and today we've got just under 2 hours. So I was looking for things that I could shortcut, and I'm afraid water is one of them. So I know that Beck will be able to make that recording available to you. And I will leave the notes and things up to her whether it's possible to share the notes with you, but certainly you could access the recording and go back and skip to that water section in there. But just know though that moisture in your soil is really critical to healthy soil food web, and then also healthy plants. Okay, so now I'm going to move on to nutrients. Nutrients are the products on that shelf in the soil food shop. And of course, we know plants need them. There are some that they need a lot of, and these are called your macronutrients. You can see them listed. And things that the plants just need a little bit of. So they're absolutely essential, but the quantities that your plants need will be very, very small. The thing is though, that the yield that you're able to achieve from your crops will be limited by the lowest common denominator. And I've just pulled this barrel picture off the internet somewhere because I think it illustrates that point really well. Whichever slat is missing and is lowest, I should say, that's the point where your yield will stop and it won't be able to get any higher. So the key is just getting these all in balance and not missing any particular one of them, because even if you've got overabundance of the others, it won't matter. Your yield is going to stop at that level. Now, firstly, I guess we need to talk about how we know whether there is a nutrient problem. And one of the things that you might see are these sorts of leaf patterns showing up in your garden. Now, this is probably not an entry-level question, but for any experienced gardeners that are listening to me today, have a look at that photo and feel free to have a guess at what you think might be happening with those leaves and why. And just leave a little strategic pause to allow you to think and type. And I'm hoping somebody will be brave enough, because it's lovely having a break from talking for a minute. Okay, lots of guesses in there. Is it iron, nitrogen, magnesium, zinc, dry soil, nitrogen, magnesium? Yes. Okay, so the one that's the most popular in there is nitrogen. And yes, that is what I think is going on as well. All the others are good guesses though. What I'm picking up on when I look at this photo, and I acknowledge it's not the best one, I wish I'd taken it from a slightly different angle. I'm looking at this silver beet plant here, and what I can see are there's some yellow leaves here. And when I look at the plant, these leaves are in the oldest leaves first. And so with all these nitrogen or nutrient deficiencies, they tend to show up as specific leaf patterns in specific parts of the plant. So somebody guessed iron, and iron often shows up as a yellowing of the youngest leaves. So it's kind of the opposite part of the plant, which is why I know it's not nitrogen. The other thing that can indicate nitrogen deficiency is the plant being dwarfed, which is not kind of full and lush and reaching its full size potential. And I'm looking at this silver beet, and it does look a little on the small side for sure. Then the next thing I'm doing is looking around the plant and going, why might this particular plant be nitrogen deficient? And I can see that there's a few other plants, yeah, they're kind of outside this photo that you can't see the full pattern of. But what you can see, and what I was trying to take the photograph of, is the wood chips on the ground here. And this is moving slightly beyond the nutrient deficiency general theory, but it's so worth understanding nitrogen deficiency and also this effect, because it pops up everywhere. It's a really good one to be aware of. So what's actually happening here is we've got an effect called nitrogen drawdown. And this happens when we've got something incredibly rich in carbon, in this case, the wood chips, and they've been put on the soil, and all those soil life creatures, all the employees in the shop, have come and gone, oh, it's a load of carbon. How do we get rid of this? Oh, we're going to need lots of nitrogen to balance it out. And if anyone makes compost, you know you need this balance of carbon and nitrogen in the soil or in the compost for it to break down effectively. So all of those microbes start to rob nitrogen away from everything else so that they can break down the wood chips. And that can lead to this short-term nutrient deficiency in shallow-rooted plants like the silver beet that are nearby. So that effect, again, I'll type this in the chat window for everyone if you want to go and research it further. Nitrogen drawdown. And this is the reason why we don't usually recommend using things like wood chips in a vegetable garden. And they are excellent for deeper rooted perennials and fruit trees. They are really not so good in a vegetable patch where you tend to have this kind of dwarf stunting effect going on. So anyway, we're going to go back now to nutrient deficiency generally. And that was just a little example of looking for a leaf pattern and then going, oh, okay, it looks like I've got a nutrient deficiency going on here. With nitrogen, you know, it's fairly easy to diagnose, and the solution would just be adding a little bit more compost or some more blood and bone or pelletized organic fertilizer or urine or whatever it is that you use to add nitrogen to your patch. But with other nutrients, particularly the micronutrients, it can be pretty tricky to diagnose them. You also, of course, you want to check your moisture and you want to check your pH to make sure that those things are not limiting accessibility of nutrients. But even if they aren't, even if you're really sure that you've got, say, an iron deficiency or a magnesium deficiency, the next question is, well, what do I do about it? And if I'm going to add something, how much do I add? And the difficulty here is that it's actually quite easy to over-apply and then create the opposite problem where you have a toxic amount of these nutrients available. So full disclosure, there are people out there who say, just buy a packet of trace elements, which you can buy as a mixed box on the shelf in many hardware stores. And they say, just apply the trace elements according to the box specifications. And I'm sure that does work sometimes, but there's a real risk in there that you're possibly over applying and also adding a bunch of other things that your soil doesn't need. And it is very possible to tip that balance out. So I would not recommend that. And I would actually recommend, if you have the resources to do it, at this point, sending some soil off to a lab for testing. Hopefully, if you've done everything we've talked about so far, it's quite rare that you would have such a debilitating nutrient deficiency that you would need to do that. But if you do have some serious issues, a lab will tell you what the issue is and exactly how much you need to apply to fix it without creating a different problem. Also, I just want to put a note in for any of you who might be really seriously going down the track of growing as much of your own food as possible. I'd say it's also quite important for you to do some nutrient testing, because if your soil is deficient in one particular element, you will become deficient in that as well over time. As I have learned the hard way with iron deficiency, which has plagued me for a long time, and part of the solution has been making sure my soil is not iron deficient, and therefore I am getting enough iron through the leafy greens and other things that I'm growing. So I'm just holding up to my video now iron chelate, which is something that I've had to apply to rebalance my soil and simultaneously myself to stay nice and healthy. So yeah, I would recommend going to a lab if you notice persistent problems just hit the wrong button there. And yes, making sure that you're doing all the things to avoid nutrient deficiencies, like cycling organic matter, for example. Yes, Jan, I can recommend a lab. I would say go somewhere where they don't sell anything besides information. Otherwise, magically, all of your problems will be solved by the array of products that they have on offer. So the ones that I have used personally are SWEP. I don't know how to pronounce it, but that's SWEP, and also Environmental Analysis Laboratory in Lismore, EAL labs up there. There's lots though, so just look around for one that sells information only. Okay, I think that's where we'll leave the nutrients for now, acknowledging that there are some questions that we'll need to come back to in a minute. Right, then we're going on to mulch. And just like I said with that nitrogen drawdown effect, we tend to use those high carbon mulches like wood chips for deep rooted trees and for shrubs. And we use these softer mulches like straw and leaves for veggies. I did see someone talk about sugarcane in the chat a minute ago, and sugarcane is a pretty tough mulch. I think it's still okay for vegetables, although I just don't have personal experience using it. If anyone does, it'd be great if you could pop that in the chat so we can learn from your experience as well. But when you're thinking about mulch, I just encourage you to think about what's free and locally accessible to you. And I have a quick video just to demonstrate what's free and locally accessible in Melbourne. And now is actually the time of year to be going out there and getting them. And these are plane tree leaves, just from those lovely leafy street trees that we have around parts of Melbourne. And it only takes about an hour to scoop up enough of them to give you a whole year's worth of mulch for free. And unlike things like sugarcane mulch, they're not wrapped in plastic and trucked down all the way from Queensland. So you can use lots and lots of different things for mulch, and it's just lovely to try and use things which are local and more sustainable. Something else that I use at home is actually growing my own mulch, and bamboo is a nice candidate for that, as you can see on the right. Lots of lovely leaves that stick around a while. And you could also grow things like comfrey for leaves. You can use grass clippings as mulch, as long as it's not got bits of rhizome that might start regrowing in your vegetable beds. The only things that I wouldn't use, to come to your question, Mary, are eucalyptus leaves, particularly that are very fresh. So if they smell richly like eucalyptus, that antiseptic eucalyptus stuff does kind of suppress soil life. So you would want them to sit in a pile for a long time until they're not smelling like eucalyptus anymore. And then you should be right to use them. I'd probably still prefer them to go on fruit trees rather than more sensitive vegetables. And Joan, no, I don't break them down first. They get eaten up very quickly by my soil and I have to top them up. And that's a product of having really fertile soil that's got a lot of life in it. And it will be an indicator, if they're not breaking down very fast, that either your soil's not got a lot of moisture or the life isn't there yet. Certainly we use them just as they are on the soil surface. Okay, in our soil shop, I've put some products on the shelf there, just to jump back a step. I've got large products on the left-hand side, and these are our macronutrients that plants need a lot of. And then I've got the little micronutrients on the right-hand side that plants must have, but only in small quantities. And I've also added a security guard, which is how I like to think of your mulch. And the reason why I've called it a security guard is it's holding on to all the good stuff in the soil and stopping them from being whittled away, either blown away by wind, washed away by water, or oxidized by baking hot sun. And of course, keeping the water there, not let anyone steal the shopping baskets, if you like. So mulch is a great friend and ally to have in your soil shop. And in our climate, I'm actually mulching all year round. And that might be very different for people in other climates where you need to let moisture evaporate if it's very soggy at other times of year. But in our climate, mulch can be a friend all year round. And also, as Nadine says, manages that weed growth as well. Okay, last big question for you. What is missing from the soil shop? I'm going to pause, take a little drink. Okay, Mary and Carol got there. Oh, sun is missing as well, but it's a more minor factor when we're looking at soil. Plants are what is missing. And in this shop, your plants are the customers. So I have quite a complicated slide here. I'm going to walk you through it. And when I first started learning about soil, somehow it just completely eluded me, that the idea that plants themselves were key to soil health. But you can test this out at home just by preparing a bed and then walking away and leaving it for a while. Because if there's no plants, even if everything else is right, it starts to just go downhill really, really quickly. And that's because plants are actually doing so many jobs for us. So starting from the left, But just by growing their roots, they're holding onto soil, so that soil can't be washed or blown away. As I said before, the plants are feeding the soil food web, so they're keeping that life engine in the soil just ticking along and humming. Deep-rooted plants are actually drawing any nutrients that might have been leached down into the subsoil. They're putting it back up on the surface in their branches and leaves and dropping it back where the topsoil and all the living forces can access it again. So they're like nutrient pumps, if you like, and that's a very important role. If we've got too much water that's falling on a soil and it starts to drain through the soil, all the soluble nutrients will start to go with it. So too much water can be quite a bad thing, and plants are what use that water, but also pump those nutrients back up again to where they're needed. So yeah, the next one is plants extracting nutrients from the soil water. If we've got nutrient-rich water that's running off, that's creating a whole lot of problems in our aquatic ecosystems, causing algal blooms and just changing the balance that can be very fine in some places. So plants are what help to keep nutrients where they're needed and also keep water clean. As we know, organic matter comes from plants, animals that are fed by plants and plants themselves, and of course their roots. So without plants, we don't have organic matter being added to the soil, and we also of course don't have all those good things that organic matter does for us. By having plants in there, the soil is shaded and it's cooler. And if we just have a bare, open patch of soil, which hopefully you will never have if you're using mulch, but if it's just open and exposed, that soil can get very hot and in summer. And if the sun is hitting it, there are nutrients that will just disappear from that soil, will just combust and go. And finally, just another related one, that plants are pushing water back out through their leaves all the time. They're transpiring, and that is reducing the leaching process that can happen if a bed is bare of plants. So plants do a whole lot of roles for us, and they're extremely important. So the message here is to try and keep those plants in your soil as much of the year as possible. And that doesn't mean you can't clear a bed occasionally, which of course we do when we're planting annual vegetables, but it means that we should try and plant that soil again as quickly as we possibly can, not leave it sitting bare for a couple of months. So somebody asked me about fallowing a long time ago and whether I leave a bed to have a bit of a rest, which is what fallowing means. I don't actually have time to do that in my rotation because it's all so small and so tight. And I compensate for that by adding compost and adding mulch, which shortcuts some of the things that fallowing would do. But when I talk about fallowing with people, the important thing is you're not leaving ground completely bare, you're leaving it planted, which in a sense is like a green manure crop. So that's fine if you've got enough space. If you don't have enough space to give a bed a break for a while, then you can achieve the same effect by adding compost, adding mulch, and so on. I hope that answers the question, but feel free to clarify it if we need to do a little bit more on there. So yes, so I've got this little clip art plugs for you in the image, and that's just representing the fact that these are plugs, and without them we've got holes and nutrients are just leaking out everywhere. So get those plugs in there and get those plants in the ground, and you should be able to maintain your healthy soil a lot more easily. So there you go, there's our little plant customer, and they've got some leaves growing out their heads to remind you that that's what they are. And I think this completes our soil shop. So it's a rather strained analogy, I know, but I do hope that helps you to visualize all the pieces of the puzzle and how they fit together. This is not my own analogy, but it's one that I've really built on over the years, and I hope you find that helpful. So the last things that I want to reiterate for you are that many factors, including plant cover, are needed to create and maintain healthy soil. But one of the most important things that you can do is to cycle that organic matter around and around and around. Always be looking for ways you can bring it back in and keep it moving. These will change, that what methods you use will change depending on where you are. So there are, and I won't go into these specific techniques now, but no-dig gardens, for example, are one way of cycling organic matter. You can't do them in a large area, so around lots of fruit trees, we just do pockets of mulch around each fruit tree, and that's enough. So we just need lots of little techniques for cycling organic matter around. It's possible to dramatically improve your soil just by keeping the moisture, organic matter, texture, structure, pH and nutrients in balance. But also equally, in some contexts, you might actually need to choose plants and animals to just match what you've got. So I think a lot of you are on a small scale, and that's great. And that means that you'll have a lot of control. But just keep in mind that you can also make a design that matches your existing soil rather than trying to amend the soil that you've got. And that's where I'm going to stop with the official content. And I'll throw back over to Beck, who I hope has been keeping track on some of these great questions that you've got. We'll see if we can synthesize some of the most popular ones and answer a few before we officially finish.
Yeah, cool. We've got heaps of questions that have come through. So we've grouped them. So I think maybe we'll start with nutrients and fertilizers. So maybe not that one. Sorry, there's a few to work through. Is it okay to add green? Is it okay to add green vegetable scraps, cuttings onto the top of mulch, or is it better to add them under?
Yeah, food scraps and things. Look, what I should say as a professional is you really should bury them, because they can attract things like rodents as well. So it's actually better to be burying them about a foot deep, and that will prevent that issue for the most part. But if they're not an issue where you live, then I usually just tuck them under the mulch, and that way you won't have any smell as they're breaking down, and it looks good and so on. Yeah, but they'll break down regardless, generally.
Nadine asked, is it always best to leave the roots in when you're finishing a season, and would there be any exceptions, like maybe tomato plants?
Yeah, you can do either, Nadine. Often I'll cut things like tomatoes off at the ground level. Those roots, when they break down, just imagine all those beautiful channels that they're going to leave through your soil. So they're a form of organic matter that breaks down in situ where you need it and creates that beautiful structure. And so I will try and leave things in the ground if I can, but I also end up pulling a lot of them out, particularly if they're in the way when I'm levering my soil open with a garden fork, for example. So I don't think there's a real strong right or wrong, but on balance, I'd leave them in unless they're in your way.
What makes soil hydrophobic, Kat?
Hydrophobic is a word that refers to when soil rejects moisture or water. So if you pour some water on the surface of the soil, the water will just roll off, or it'll sit in a little bead on the surface. And this can happen, surprisingly, with sand or with clay soil. So it's not related to the texture of that particular soil. It happens when soil has usually dried out, and it's actually a fungus that creates a wax that creates that barrier that stops moisture from getting into the soil. Just incredible. So the question about, like, what do we do with hydrophobic soils? I would mechanically break them open, as in open them up with a garden fork to create physical channels that moisture and compost and things can drop into. I would be adding a lot of compost back to that soil, and then I would just be standing there with a hose and really forcing water into it, and it will come good again, but it just needs a bit of a shove to get that moisture and get the moisture holding compost back in. Yeah.
Cool, Kat. I might just we might just do one more question, and then what I'll do is I'll just take a few minutes to wrap us up, and then we'll continue answering questions after 4. I just really want to formally wrap us up by 4 o'clock, and then we can do with some more questions, because there's definitely lots. So Joe had one about green weeds for green manure. is it best to solarize weeds before using them as a soil nutrient? She has couch grass and she's trying to lessen, but it's a big job, she says.
Right, yeah. Okay, so there are some weeds which you won't need to do anything to. There are some weeds like couch grass and kikuyu grass. They're the really rhizomatous, tough, drought-hardy grasses that a lot of people have as lawns. And they are a definite problem in your food garden. They're super competitive. They're really hard to control and to kill. So they're one of the only things that I would really think hard about adding back to your vegetable garden soil, because if they're not, sorry, my cat's just having a bit of a brawl over there. So if you just got to be so careful that they're properly dead. So I would definitely solarize those and make sure that they're proper dead straw before you're adding them back in the vegetable garden context. But there's a lot of weeds that don't really spread by rerooting and that haven't developed the seed heads yet, and you can use those freely and there's no problem there. Chickweed, for example, I've got heaps of it, doesn't matter. We eat a lot of it, we feed it to our quails, I pull it out and I leave it on the surface and there's no issue. So it's about getting to know your weeds and knowing which ones are going to regrow easily and which ones are just going to die as soon as you pull them out and leave them on the surface. Couch and kikuyu deserve a special mention though, because they really are so hard to properly kill off. So they're one of the few things that I probably would think about asking my neighbours if I could stick a handful of them in my neighbour's green from time to time, just to be really sure. We also have a really small garden, so it's not like I have a space where I can just put things for a while until they're dead.
All right, cool. Well, on that note, I might just take a couple of minutes. Firstly, just say thank you so much to Kat for the session today, for just sharing so much of her knowledge.
Du stjäler mitt papper.
Just going to mute that one. It's just been such an informative session. I think everyone who's kind of been tuning along has probably gotten so much out of it, and I guess soil is one of the really complicated elements about gardening, but I think, Kat, you have a way of making things really clear and easy to understand and highlighting the bits that are the most important. So I hope everyone's feeling a little bit more confident to understand their soil and know how to improve it. I just want to wrap up this webinar with making a request of all of you. I do like to ask that you just take a moment after this session to reflect on the session and just think about one action that you might take, maybe today, the Savo, this weekend or this week, to apply what you've learnt today. So, it could be testing your soil, and I'll send out the instructions from Kat. Maybe you'll test the pH of your soil. Maybe you'll change how you incorporate compost. Maybe you'll stop stepping in your soil or make some clear pathways. Or maybe you'll be trying out some different crops to match your soil. So I'd just love for you to think about that and just even, make a note, write it down, write it in your phone, one thing that you're going to apply, or share it in the chat box now. A reminder that this webinar today was the second of 4 webinars with Kat. So the next one is about plant propagation, and that's not going to be next Saturday, but it is actually the following, so that's the 13th. Next weekend, we've actually got a workshop that's all about habitat gardening and growing a garden for wildlife. So that's next Sunday, and I'll send out all of these details in the email following this. Kat's last webinar will be on managing garden pests, which has been a super hot topic in the chat box in both sessions, so I think it will be a popular webinar. And then the series that I'm running will finish up with a workshop on keeping backyard chickens. So if that's of interest to you, I definitely encourage you to come along. I'll include booking details in my email. And for those that have asked, I'll share the recording for today's session, also last week's session, plus the notes that accompany both sessions in the email after this webinar. If you are interested in the future sessions but can't attend them, sign up for them, and that way you'll get the email with the recording in them as well. So yes, one thing I'd like to mention just about Stonington. Stonington Council does offer discounted compost products for our residents. So you can buy discounted worm farms, compost bins and bokashi bins, and some accessories that go with those. And we have a discount of 40% off. Lots of councils also offer these discounts. So if you're not in Stonington, you can still check your address and see if you're eligible for a discount. And that is through, it's called Compost Revolution, but I will send a link in the email after this. One last point I just want to remind particularly Stonington residents of, we have declared a climate emergency. We're currently seeking our community's ideas on our climate emergency response as a council. We want to hear your ideas of what a sustainable future looks like in Stonington. So maybe you want to see more support for gardening or more street trees or more cycling lanes. It's really important that you let us know. So I will share a link of how you can contribute to that process there. So huge thank you to Kat for spending this Saturday afternoon with us today. Thanks so much also to Deb, who's been behind the scenes helping me with questions. Thank you to every one of you who joined us. We had 100 participants on this meeting today, which is awesome. Want to wish you best of luck with your garden and hope to see you at one of our events coming up soon. So on that note, let's head to some more questions because I know there's been heaps. And I think Deb's been helping me to consolidate some. So maybe we'll just return back to nutrients and fertilizers. Are fungi that pop up in your veggie patch okay, or should they be removed?
Yeah, they're probably not a problem in your patch. I mean, it's a good sign that you've got fungi in there. The bad news is that it means there's sometimes not a lot of diversity, because if there's a lot of fungi competing, often one of them won't be able to suppress all the others and produce fruit. But no, there's no need to worry about them unless there's a risk of someone eating them, and of course we don't know what they are. So if you need to remove them for safety because of pets or children, I'd do that, but otherwise I don't worry about them at all.
Thanks, Kat. Someone's asked, once a nutrient problem is fixed, do you need to keep managing it over time, or is it once off?
Yeah, it's a great question, and it's hard to do anything permanently in soil because it's constantly in flux and changing, particularly in areas where you're harvesting a lot and reapplying things like compost or other amendments. There's just so much change in there that you will find you need to keep monitoring things. But sometimes you can add enough of an amendment to give you a couple of years without needing to interact. Sometimes it's permanent, but yeah, often it'll be just a continual monitoring process, particularly if you've got a really serious imbalance in your soil.
And a question about horse manure, and also one about pet waste. Would you recommend horse manure?
Horse manure can be fantastic, and yeah, it's been used for a long time in vegetable gardens. The best advice for manures is to age them, as in let them sit in a pile for a long time, or compost them before you use them, just because of a low risk of pathogen transfer from an animal like a horse. There is a very high risk of pathogen transfer with cat and dog manure, which is why we don't use that in food gardens. I've got a cat and he does take a poo under fruit trees, and I'm okay with that because the parts we eat are a very long way away. But I'd be very concerned about them getting into vegetable crops, particularly if it could have contact with an edible part of a plant. So yeah, best advice is to keep cat and dog poo away from food gardens, or at least away from all the parts of the plants that you would touch and eat. Yeah, also on horse manure, if the horse has been recently wormed, then of course that medication can then have an effect on life in your soil as well. So I always ask, when was the last time that this horse was wormed? And yeah, prefer for it not to have been very recently, ideally. And race horses apparently get fed a lot of things that you might not want to have in your soil. So just ask a lot of questions. There's not a lot of great science out there to prove what is safe and what is not safe. So your best bet is to just go with a horse that hasn't had any medications recently.
I'm going to do one question on soil types, and then we might go into compost because there's a whole bunch of questions around that. So Lorraine asked how you suggest dealing with a site that has several types of soil.
Well, the great thing about soil is that all the things that we've just talked about will lead to healthy soil no matter what your soil type is. So it's actually very lucky, actually, because it'd be very complicated if you needed to do extremely different things. But all the general things about balancing pH and adding organic matter, correcting the structure, all those sorts of general things, I do them everywhere and it will always help. But if you've got a patch that's 1 pH compared to another, or if you've got a really clayey patch compared to a really sandy patch, then you'll just need to introduce those little different approaches. Like you might add some gypsum for the sandy patch, or you might add a little bit of lime to the very acidic patch, for example. And also just on that, if you've got different types of soil on your block, that can be a huge advantage because there will be plants that are better suited to one soil type or another. So it actually gives you great diversity and great options in your design once you learn about those soils a little bit more. So I would do the general things as a blanket across all of them. I would correct any serious imbalances individually depending on what they needed. And I would think really hard about how I can use those different soil types to the best advantage with what I'm growing.
Awesome. Good answer. So maybe we'll do some questions about compost now. And maybe we could just start with your best recommended resource for compost, because there's a whole bunch of questions about managing it well.
Yes, and I'm very conscious that like it's such a key skill, and I've talked all through the session about how important compost is, and of course we haven't actually run a compost prac or even a lesson on compost, so I am sorry about that. It's just I felt this session would be better to do like a thorough overview of how soil works, and also because composting is a really common workshop that I know councils like Stonington run all the time. So, and it takes about 45 minutes for me to teach composting at a really thorough level. And it's just not something that we were able to squeeze into this session. So one of the best resources will be the Stonington workshop program, where I'm looking at Beck to see whether she knows if there's one booked in at the moment. But I know that these workshops will be available in the future through Stonington and other local councils, and it's a great idea to actually go along to one of those.
We have one coming up in the next few months, maybe later in the year, but often councils run them. So if you don't live in Stonington, check your local council. Otherwise, I'd just hop on Google and Google compost webinar and see what comes up, and see if there's a local council offering one. Otherwise, Sustainable Gardening Australia is a really good online website resource that has really good information on composting. So that's a good place to start.
It's not difficult to learn composting, so I'm sure any of those resources will give you the basics. So yeah, I'm sorry I haven't got into a lot of detail on those today, but I'm sure you're going to be able to find the right information in another place.
Yeah, and I'll just remind you to sign up to the Stonington Environment newsletter to find out about any composting workshops that we run. So Kat, what about, quite a few people have asked about the amount of compost, like a percentage, and maybe like, can you add too much?
Yeah, okay, as in how much to add of the compost? Yeah, this is a really great question. It took me a long time to work out an answer to it, and because often the books will say add compost and they just neglect all the details around how much and when. And so I've got my own experience growing food successfully now, and I ask a standard set of questions to any market gardener that I meet, and there's a comforting level of consistency. And so what I can share with you about the composting is that everybody seems to add around an inch, and I get told off for using inches, so I have to say 2.5 centimetres, which sounds very precise. I don't mean it to sound precise, but just, around that much across the whole surface of your bed. So not around each individual plant as a little pocket, because plants will put their roots everywhere in those veggie beds. So you want the whole surface of the bed to get a nice even layer, about 2.5 centimetres thick of compost. And annual vegetables will need that pretty much, every time you're replanting them, which could be twice a year like it is for me. Fruit trees, there's a little bit more leeway there because they've got a big root system and they can forage a little bit further for their nutrients. But I am chucking mulch on them all the time. They get a few peas around here as well, which is fine. So they're getting nutrients and things from other places. So I go a little bit more lax with the fruit trees, but the annual vegetables really do need that constant compost top up. There was another part of that question, Beck, was there? Did I miss a part of it, or is that?
I think it was just about the percentage, how much and whether you can add too much. So I think
that's right. Yeah. So I don't tend to think in terms of percentages for things like that. I just think about the rate. Remembering back to that chart at the start that had the components of soil, compost or organic matter, healthy soils have about 5% to 10% of it. But it's actually really hard to know how much you've got in your soil unless you do a soil test for it. So it's not very helpful as an indicator for home gardeners. If your soil's got lots of organic matter, it will look darker and richer, and you'll come to know over time for your soil type what it looks like when it doesn't have enough, just by looking at that colour change. And it's really difficult to add too much, but you can certainly waste it because above that level, you're not getting better plant growth or healthier soil. And it is precious stuff. It's really difficult to make enough of it on a home garden scale to supply a large vegetable patch. So we do our absolute best, but I still sometimes need to either buy in compost or buy in carbon materials that go into our aviary and then become a larger amount of compost. So you wouldn't want to be paying for something to come in and then using it at a level which is not justified. Yeah, I can see Tara's got her hand up. Is this a follow-up, Tara? Should we go?
Yeah, let's go, Tara.
Great.
Sorry, quick question with because you've talked about putting compost on the top on surface of a garden. If you're working purely with wicking beds, is that going to be an issue for the plants accessing that nutrient if they're mostly drawing it up, or will watering just for the period that you've got small seedlings be enough to bring those nutrients down?
Yeah, it'll be fine if it's left on the surface. Are you sort of conscious, Tara, about not sticking a fork in your wicking beds and puncturing a hole in the liner? Is that the hesitation in putting it into the soil a bit?
No, I just was curious to know whether it's better to dig it down a bit deeper if you are using a wicking bed purely because you're not going to be doing much top watering.
Oh, I see what you mean. Yeah, okay. Look, I would probably bury it in a little bit into the soil. The soil life do incorporate anything that you put on the surface into the soil over time, but they often, things like worms don't come up into the very surface as much, so it's easier for them if it's under the soil a little bit. And so moisture does, and rainfall in your watering does leach out some nutrients down to the plant roots, and probably does that quicker than the stuff gets broken down by soil life. But all of it will work, I guess. If it was my place, I'd still mix it in gently into the top few inches of soil. Yeah. Sometimes there are not definitive answers to these questions. I try and be clear about whether it's personal preference or whether it's based on some evidence.
All right, well, there's another one about what to avoid composting. So would you avoid trees with fungal problems or stone fruit branches?
Okay, yep. So the logic behind that is if you've got a plant that's affected by a disease, like a fungal problem, for example, the theory is that if you then compost it, that fungi will re-emerge in a nastier, more aggressive form and then take over more of your plant the next year. And that is, like, it's the advice which you get from good horticulture sources. I have to say, though, that I have been, when I say composting, I mean just actually leaving this stuff on the ground under the vegetable or under the fruit tree. I've been doing that for things with powdery mildew, like zucchinis at the end of the season. I've allowed leaves to drop that have peach leaf curl on them, which is a common fungal disease in the stone fruit family. And I can't honestly say that I'm getting worse problems every year. It actually doesn't seem to check out from my personal experience. So I don't know where that leaves you. So you've got to draw your own conclusions here. But all I can say is it's possible it won't be a problem, but I can't swear that you won't ever have a problem from doing it. So if you're concerned, then they say just put those in your green bin. And the green bin goes to a commercial compost facility where it gets heated up over 65 degrees, which is enough to kill any pathogenic fungi that are present. So you're not creating a problem for someone else. So that's an option if you've got a green bin. You just don't have to think about it. But yeah, I just can't say that it's really been a problem at my place. So I do allow things to go into compost which have fungal issues.
All right, I've got a couple of questions about mulch, although I think you may have answered the first one, which is whether or not you break down homemade mulch like tree leaves before applying. I'm pretty sure you said you just chuck them on whole.
I do chuck them on whole. When I'm doing chop and drop, which is the very loose technique that I use when I'm pruning fruit trees a lot, and so this is just chopping the branches up into 10 or 15 centimetre lengths and just leaving them underneath the tree on the surface of the soil. I do chop them up then because I want them to have contact with the soil. If I just leave a whole branch, it's going to dry out rather than start breaking down. So I just chop those up enough that they've got nice close contact with the ground and they can stay nice and moist. But yeah, I really don't bother chopping up any other mulch. Yeah.
And Sarah has asked a specific one about black painted bark mulch. I'm not sure if you know what that is, Kat.
Yes, there are some mulches that are for sale that have actually got a dye added to them, and I don't really understand it, I have to say. I think it's a total cosmetic thing. You can get red mulch, you can get black mulch, and unfortunately I'm not going to be very helpful to you because I have no idea how they dye them. I would tend to avoid things like that unless you've got a really good source on what they've put in them. Just stick with your normal undyed natural mulch as much as possible.
Thanks, Kat. I'm not sure if I missed this, but there's a couple about commercial compost and whether it's good, bad, or to stay away from it. So maybe can you answer that one? Yeah,
I can. That is a tricky one, and that's part of the problem is you've got no idea what you're buying when you buy commercial compost. It's highly variable, and I know there are standards for it, but you definitely don't have like a standardized product when you're buying compost. So some of it is really high quality, particularly vermicompost or worm castings. They tend to be excellent but quite expensive. And mushroom compost I often highlight to people because that's a bit cheaper, and that is very consistent because it's come from the mushroom growing industry, so it is by nature going to be a very consistent product. Mushroom compost, just a bit of a red flag. If you have a very alkaline soil, mushroom compost does tend to be a bit alkaline, and so it could actually make an alkaline soil problem worse. But unless you've got that particular issue, that would be my go-to if I'm buying compost to bring in to a site. Then there's all the other things that are sold as compost, which can be anywhere from bark, from what I can tell, just sort of lightly composted bark, through to random mixes of soil and green waste and bits of glass and plastic, which unfortunately comes through some of the green waste collection services. That, I should say, has gotten a lot better in recent years, but it's really worth checking out because I know everybody's from different places. Really, really worth checking out what you're getting if you're getting compost from a kind of municipal collection system, because I've had some very bad experiences, unfortunately, through that. So there's this huge range. So I can't say commercial compost is good or bad. I can just point to the sources that are likely to be the best, most consistent, good compost, and also of course encourage you to make your own as much as possible, because you will probably make better compost than anything you can buy anywhere else once you've learned how to do that.
Cool. I think what we might do now is there's still 57 people in the meeting. So if anyone's got a question that we haven't addressed, can you just pop it in the chat box, and we'll try and get to some of your burning questions rather than answer some that for people who might have left. And sorry, hopefully you can hear me. I'm not sitting a little bit closer to my microphone, so I think I'm a bit quiet.
Oh, there's a good question from Nadine. Are the principles the same in pots rather than garden beds? Yes, absolutely, Nadine. It's all the same. I should say another area where I differ sometimes from standard horticultural advice is you will usually read to use high quality potting mix in pots rather than soil. And I know that works, but I'll say that all of my pots are full of soil and they're all producing really well. And it's probably quite important that your soil has good light structure, and it's got lots of pore spaces, and it's maybe a bit on the sandy side, because you can imagine how heavy clay could really set hard in a pot and maybe not be good. But I just have great results with the sandy soil mix in all my pots, and I find it a lot easier to keep it moist than the commercial potting mix, which sometimes just seems to dry out so quickly in summer and then be really hard to wet again at the end of that. Yeah.
Greg has asked about fallowing, which you did address.
Okay.
Cat urine on soil and how you neutralise it.
Okay. Well, try not to let them pee on soil where you're growing food crops. Yeah, that's probably all I have to say on that one. Neutralising, I don't know whether that means neutralising pH or whether it's just avoiding the impact of it. Look, urine should not be a very rich source at all of any microbes, either from humans or from cats. If you're healthy, it's like it hasn't got a lot of stuff in it. It's more the poo that we worry about. So yeah, don't panic about that, but do try and keep those animals out of your food garden as much as possible.
I think the questions have stopped rushing in, and we've addressed the last few for people that are still here. So if no one has any more questions, I think, Tara's got one. That's a raised hand. Go for it, Tara.
Sorry, just a quick one. Just with crop rotation, I'm interested in, because I've set up, so I've got 4 wicking beds, and I'm just interested because you've talked a lot about not disturbing the soil, and so I was actually going to replace the soil like 1 bed per year sort of thing completely, in terms of like turning it over, but now I'm thinking maybe that's a really bad thing to do. So I'm just wondering what your suggestion would be in terms of, obviously with an enclosed container like that, you can't continually add without taking away. So how you would suggest going about that?
Oh, okay. Yep. All right. There's a couple of things in there. Well, firstly, and this links to something that somebody else asked as well, won't the soil just get bigger and bigger and bigger as you're adding organic matter all the time? And it actually won't, because organic matter is getting used up by plants over time. So your soil, if you do nothing, will actually recede to the point where that organic matter's gone out of it. So you won't have the problem, as long as your soil is healthy and it's digesting and eating this stuff. You're not going to have this issue where it just grows and grows and grows and grows like that. I know that's not quite what you're asking, Tara, but you just reminded me of.
No, but that makes
sense. Yeah. So when I say don't disturb soil, it doesn't mean you can't do big complex digging maneuvers and things, and in gardens you often need to do something like that. It's more about just not thinking that you need to get in there with a spade and just dig the whole bed frantically every time you're planting. I don't think it adds anything, and you're probably doing real damage to that delicate soil food web that's in there. So it's just about, like, when you don't need to get in there and dig, just do something else like forking the bed open instead. Then you're asking about the crop rotation, and when I started doing gardening and reading lots of gardening books, you just read about crop rotation, and you freak out because you go, I've got a really tiny space and I can't manage this, so I'm going to have to bring in soil or all my plants are going to die. And the great news is that that doesn't seem to ever happen. And I actually have never had anyone come up to me after these workshops, and I'll keep saying it and hopefully it'll keep happening this way. Nobody comes up and says to me, I can no longer grow veggies in soil that I used to grow veggies in. So it's not that I don't believe in crop rotation, but I don't believe that it is as big an issue as it is sometimes presented to be. There are two reasons why you would rotate crops. And so this is about not planting the same plant in the same soil again and again, year after year. The first reason is because of potential buildup of pathogens in the soil. Things like nematodes that get a really bad reputation, even though most of them are good. They talk about nematodes building up and building up, particularly for the tomato family, which includes potatoes and capsicums. So they say, don't plant that family in the same soil again for another 3 or 4 years and just rotate them around your garden. That's one reason. The other reason to do crop rotation is so you're not constantly drawing the same balance of nutrients out of the soil that one particular plant or family of plants requires. So if you put beetroot in the same place for 20 years, that soil will really quickly become depleted of everything that beetroot needs a lot of. And by rotating the crops, you just draw more evenly from the nutrients that are in your soil. So this is a very long answer, I'm afraid. So firstly, the problem with the pathogens, it just doesn't seem to be as big an issue. So I encourage people to do as much rotation as you can manage, but don't let your head explode, firstly. And if you can't do it, don't worry about it. Just keep your soil really healthy and keep adding compost. And compost contains billions, literally billions of organisms that are all in competition with those things like nematodes. So they are going to have this effect of suppressing anything that wants to get out of control. And I try not to worry about those things unless they become an actual problem, because it's such a headache as you've kind of experienced thinking about how to deal with them. So yeah, do that. Yes, that's what I'd suggest. So rather than thinking about replacing soil, just do the best that you can, keep that soil really healthy, and then deal with any of those problems if and when they become a real problem.
Thank